Now that we've set up an initial rigid body sim, let's start exercising a little bit more control over this simulation and doing something a bit more interesting. Now, most of our setup will happen in SOPs rather than inside the DOPNet here. And if you pull up the Houdini help file and go to the RBD packed object doc, you'll see the first section here is for point attributes. You can click that or just scroll down a little bit and you'll see a whole list of attributes here that you can set on the points of your packed pieces to override the sim behavior per piece. Make sure that the name matches exactly and that the data type is correct and matches what's listed here. And most of these we don't have to worry about. They're really just a handful that we use pretty commonly. And in this video, we'll focus on this active attribute. Active pieces in your sim will be simulated by the solver and move and collide, whereas pieces that are not active will simply be non-moving colliders. And to be a bit more accurate, inactive pieces can be moving. They won't be simulated by the solver, but they can follow transform animation from SOPs or deforming animation. The key is that their actual motion won't be simulated. Now, one way that we can set up that active attribute is by setting up an active frame attribute on each of our pieces, and then just before the sim, we'll compare the current frame to that active frame value and set the active attribute accordingly. So you can set the active frame in many ways. You could randomize it per piece. You could set a fit range to be based on the bounding box of the object. But one of the most common ways of setting up an active frame will be based on the proximity of some sort of animated object. So we'll import our monster here to use as our activator object. Let's pull this to the side and we'll object merge, and in our merge we'll specify object, assets monster, and out monster. And now with our monster imported, we can convert this into a VDB, and we'll just use some basic grouping and determine when the monster intersects with our rigid body pieces. So we'll just do a VDB from polygons. Maybe I'll increase that voxel size a little bit because this doesn't need to be very accurate. A low res volume is absolutely sufficient. And oftentimes with an activation object like this, you want to expand it a bit so that pieces get activated whenever they get near the object and they don't have to touch it exactly. So let's just try expanding this. Maybe 10's a little bit too extreme. You can try something like 3, seems like a good starting point. And one thing that's very important about setting up these active frame values and ultimately the active value is that once you have this set to active, you never want it to revert back to inactive. So it's not enough to just compare on every frame to see if the monster's touched it. We need to accumulate across all of the frames and determine what the earliest activation frame is and make sure that never changes later. So whenever we're doing some sort of an accumulation effect like that in SOPs, we can use a SOP solver. So if you type in solver, we can connect our sim pieces to that, and we can connect our VDB to the second input. And I like to set some really high default active frame value so that everything by default will maybe have a value of 10,000 for their activation frame. So if they're never touched by this monster, they'll ultimately never activate. So we'll just drop in a point wrangle, and I'll just say active frame default. And in this expression, I'll say I at active frame equals 10,000. Maybe before we run this solver, I'll also reduce that reshape a little bit because this is looking maybe a little bit extreme with that expansion. And then we can dive inside the solver. And I've mentioned previously that anytime you use a subnet, you want to make sure to use an output node at the end so that you don't accidentally set your display flag to the wrong node and output the wrong result. And the same thing is true for a SOP solver. So always create an output for the end. And if input 1 is our geometry and input 2 is our monster, we can just use a group node to figure out what is currently being touched by that monster. So we'll connect input 1 to the first, input 2 to the second. We'll set the group type to be points, and we'll call this activate. And we want to turn off that base group and turn on bounding regions, set it to bounding volume. And if you middle mouse on that, you can see our activate group is currently detecting 196 pieces that our monster is currently touching at this frame. If I control template that second input, you can see sure enough, he's touching a whole bunch of pieces over there. Now once we have this activate group set up, we can set our active frame value based on that, and we'll do that in a point wrangle, and we can connect that activate group to our wrangle node. And then in the Vexpression, we're going to check to see if each point is in that activate group. Now whenever you're working in Vex, you can use a bit of shorthand to check a group as if it were an attribute. We can say if at group underscore activate is equal to 1, then we'll set the active frame value equal to the current frame. Now if we just leave this as it is and connect this point wrangle to our output, then every time a piece gets touched, it's going to get a new active frame value. And we want to make sure that once it gets an active frame, that it maintains that earliest activation and it doesn't get overwritten later. So we'll need to compare on each frame our current activation to the previous frame to find the minimum. So we've got this previous frame in our SOP solver here, and you can connect that to the second input of the wrangle. And we'll set the active frame equal to the result of the minimum vex function, and we'll pass in the current active frame, and then we'll look it up from our previous frame with the point function, looking up input 1, the active frame attribute for the current point at ptnum. And we can rename this to accumulate active frame, and then we'll go out to SOPs to test this. Now this isn't a requirement, but I often like to use a time shift at the end of the SOP solver to force this to give us the result at the end of our overall time range. In some cases, when using a SOP solver, this is important. In some cases, it's less so, but I find it cleaner to work this way regardless. So you can create that time shift, Control-Shift-Click to remove that frame expression, and set that to 1150, and let this run for a moment. In my case, this is taking, looks like a little bit over 30 seconds. And then once that's finished running, we can test this both by looking at the spreadsheet to see if it looks like we have reasonable values across our geometry. It looks like we're getting a good accumulation of various values, but it's better to test this with a blast node. You could go ahead and try this in the sim, but you can often save yourself a lot of trouble if you test this in a non-sim way first. Now in this blast node, I'm going to type active frame is less than or equal to the current frame, but that current frame variable needs to be in quotes in order to evaluate properly. You can middle click on that group parameter to make sure that it's returning the correct result, and you can see it's checking the active frame against 985 because that's the frame we're at, and you can see that updating if we move around in time, which would not work correctly without those backticks. However, in order to get this blast to work correctly, we have to set the group type to points because active frame is a point attribute. And with that active frame check set up, I'll rename our blast to check activation. And then if we scrub through our timeline, you can see these pieces being deleted as they're activated by the monster's intersection. It's a little bit hard to see with this gray on gray, but sure enough, if you look closely, you can see all those pieces are disappearing when he touches them. Now, if we refer back to the RBD packed object doc, you'll see the actual attribute we need to set is called active, not active frame. So before the simulation, just before our sim piece is null, we'll need to add another wrangle to set that active value. So just drop in a point wrangle. I usually just call this sim adders because in the future we might be setting a lot more in this attribute wrangle aside from just the active value. And then in this vexpression, we'll type I at active equals at active frame is less than or equal to at frame. Now this conditional statement, active frame is less than or equal to frame, will always return 0 or 1, 0 if it's false, 1 if it's true. So this is a good shorthand to set that active value. And it's also worth noting that all of the attributes that we care about need to be on points. You'll notice that the name attribute is listed as one of those point attributes here. Although our initial sim worked without our name attribute being pushed down to points, you can see by default with our setup so far, our name attribute is on prims. We really should make sure that our name is a point attribute for it to be used properly in the simulation. So I always add in an attribute promote just before the simulation to promote from prims to points and select that name attribute. Now we're almost ready to run our sim, but anytime that we have changing values in SOPs, like this active attribute, and we want those to be picked up in our simulation, we have to tell the RBD packed object to overwrite those from its input. So diving inside that DOPNet and going to this RBD packed object node, you can see there's this overwrite attributes option that's turned off by default. So you can turn that on, and this will default to overwriting the active, animated, and deforming attributes from SOPs. At this point, we're not using animated and deforming, so it doesn't really matter if those are there or not, but it's very important that we specify active as being overwritten per frame. So now with that active value updating turned on, we can jump out of our DOPNet and run a new flipbook to see what this updated sim looks like with this custom activation. And now after letting that run for a couple minutes, our flipbook is done, and you can see our per frame activation is working correctly based on contact with the monster.